أعزائي طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج داينامكس. النهاردة إن شاء الله هنستعرض مع بعض موضوع نيوتن ثيرد لو. سبق وتعرفنا على نيوتن فيرست لو ونيوتن سكند لو. النهاردة هنشوف نيوتن ثيرد لو والابليكيشنز اللي جاية على هذا الموضوع. Dear students of grade 3 secondary, welcome to our math program. Today we have dynamics. Our lesson today is Newton's third law. Newton's third law: to every action there is a reaction equal in magnitude and in an opposite direction. The discussion of the law start with application of Newton's laws. First, a body is placed inside a lift moving vertically. Then, consider a body of mass m is placed on the floor of a lift or is attached to the end of spring balance suspended from the top of the lift. Consider a body of mass m is placed on the floor of a lift or is attached to the end of spring balance suspended from the top of the lift. What is the forces acting on the body? The forces acting on the body: number one, the weight force, vector W, of magnitude mg and acting vertically downwards. The second force, the reaction force or the tension force of the spring, which equals n vector or vector t of magnitude n or t and directly vertically upwards. Let I vector be a unit vector in upwards direction. Thus we can write Newton's second law in the form F equals ma. F is the resultant of the two forces acting on the body. Then Ni minus Mji equals Ma. N in the positive direction of motion and the weight Mg in the negative direction of motion. Then Ni minus Mgi equals Ma, or N minus Mj in direction I equals Ma. In case of we have a reaction. But if we have a tension, then Ti minus Mgi equals Ma, or T minus Mgi equals Ma vector. The first case, the lift is at rest or moving with a uniform velocity. When the lift is at rest or moving with uniform velocity, then in this case the acceleration vector A equal 0 vector, and the equation B, n equals mg or t equals mg. The first case, the lift is at rest or moving with a uniform velocity, then the acceleration vector A equals 0 vector and the pressure n equals mg or the tension T equal mg. And we can note that the pressure of the body on the ground of the lift is equal to the real weight of the body, n equal mg. But in the second case, the lift is moving upwards with a uniform acceleration. The first case, uniform velocity, means the acceleration equals 0. But in this case, the body moving upward with a uniform acceleration, then vector A equals I in direction I, in the positive direction of I. And the equation written as n equals m multiplied between two brackets g plus a, or t equals m multiply g plus a. In this case, the pressure of the body on the ground of the left is greater than the real weight of the body. In this case, if the pressure greater than the real weight, the left is moving upwards with uniform acceleration. And the third case, the left is moving downwards with a uniform acceleration. Then, in this case, vector A equals negative A vector I, and the equation written as N equals M multiplied between two brackets G minus A, or the tension T equals M multiply G minus A. And we notice that the pressure of the body on the ground of the left is less than the real weight of the body. Now we have three cases: the left at rest or moving with uniform velocity, or the left moving upward with uniform acceleration, or the left is moving downward with a uniform acceleration. Now let's start with the first example. A man of mass 80 kilogram is inside a lift. Calculate in kilogram weight the pressure of the man on the floor of the lift in each of the following cases. Number 1, moving upwards with uniform acceleration of magnitude 49 centimeter per second squared. Number 2, moving with a uniform velocity of magnitude 80 centimeter per second. The third case, moving downwards with a uniform acceleration of magnitude 89 centimeter per second square. Now, the pressure exerted by the man on the floor of the lift is equal in magnitude to the reaction of the lift on the man. And the lift moves upward with an acceleration of magnitude 49 centimeter per second square, or 0.49 meter per second square. Now we use meter per second square unit for acceleration. What is the equation now? The equation MA equals N minus mg. The left moves upward, then the positive direction upward. N minus mg equal MA, or MA equals N minus mg. What is the mass of the man? 80 kilogram. 80 multiply. What is the acceleration of the lift? 0.49 meter per second square. Now I use mass in kilogram and acceleration in meter per second square. Then the force N or mg must be in Newton unit. N minus 80, the mass of the man, times the gravity G, which equals 9.8 meter per second square. Then N equals 80 times 9.8 plus 80 times 0.49. Then the pressure N equals 823.2 Newton. This pressure in kilogram weight equals 823.2 divided 9.8. Then the pressure N equals 84 kilogram weight. The second case, the lift is moving with a uniform velocity. Uniform velocity, then the acceleration of the motion equal 0. And N equals mg. N equals m, the mass of the man, which equals 80 kilogram, multiply g, the gravity, equals 9.8 meter per second square. Then N equals 80 times 9.8 Newton by divided by 9.8. Then N equals 80 kilogram weight. The third required, the lift moves downwards with a uniform acceleration of magnitude 98 centimeter per second square or 0.98 meter per second square. Now the left move downward, then the positive direction is downward, and the equation MA equals mg minus n. mg here positive and n negative. M is the mass of the man, 80 kilogram, multiply the acceleration of motion, 0.98 meter per second squared, equals 80 times 9.8 meter per second square minus n. Now we use units of Newton for the force n. Then n equals 80 times 9.8 minus 80 times 0.98. Then n equals 705.6 Newton, which equals 705.6 divided 9.8 kilogram weight, or n equals 72 kilogram weight. Another example. A body is suspended by a string in a spring scale fixed at the top of a lift moving upwards. If the magnitude of tension in the string during ascending with an increasing acceleration of magnitude 2.45 meter per second square is equal to 50 kilogram weight, find the mass of the body and what is the magnitude of the tension if the lift moves down with the same acceleration. First, the lift moves upwards with an acceleration of magnitude 2.45 meter per second squared. What is the equation of motion now? MA equals T minus mg, because T in the positive direction and mg in the negative direction of motion. Then the equation of motion is MA equals T minus mg. Now m times 2.45 equals 50 times 9.8 minus m times 9.8. m times 2.45 plus m times 9.8 equals 50 times 9.8. Now we can take m as a common factor in the left hand side, then m multiply between two brackets, 2.45 plus 9.8 equals 50 times 9.8. Then the mass equals 40 kilogram. Then the mass of the body equals 40 kilogram, and the lift is moving upward with an acceleration of magnitude 2.45 meter per second squared. Now the second required. The lift moves downwards and the acceleration equals 2.45 meter per second square. The same acceleration. What is the equation of motion? Yes, mg is in the positive direction, but the tension T in the negative direction. Then the equation is MA equals mg minus T. The mass is 40, the mass of the body is 40 kilogram, times the acceleration 2.45 equals 40 times 9.8 minus the tension in the string. Then T equals 40 times 9.8 minus 40 times 2.45. We can take 40 as a common factor in the right hand side. Then the tension T equals 40 multiply 9.8 minus 2.45. And the tension T equals 294 Newton. The tension in Newton unit, and we can find the tension in kilogram weight unit by dividing 294 by 9.8, then the tension equal 30 kilogram weight. Dear students, let us move to the next example. A lift moves vertically upward with a uniform acceleration of magnitude 140 centimeters per second square, and a person is inside the lift. If the pressure of the person on the floor of the lift is equal to 72 kilogram weight, calculate the mass of the person, then find the magnitude of his pressure on the floor of the lift as he moves downward with the same acceleration. Now, the body of mass M is placed inside a lift, moves vertically upwards. Then, the equation of motion of this body, knowing that the acceleration equals 1.4 meter per second square or 140 centimeter per second square, and the pressure N equal 72 kilogram weight. Then the equation of motion is MA equals N minus mg. The mass M times the acceleration 1.4 meter per second square equals N, the pressure, is 72 kilogram weight times 9.8, then 72 times 9.8 in Newton unit, minus M multiply gravity G, which equals 9.8 meter per second squared. Then M multiply 1.4 plus 9.8 equals 72 times 9.8. Then 11.2 M equals 72 times 9.8, and the mass M equal 63 kilogram. The second required, or the second case, the lift moves down with an acceleration of magnitude 1.4 meter per second square, the same acceleration, or 140 centimeter per second square. Then what is the equation of motion? Yes, MA equals mg minus N. The mass of the body equals 63 kilogram, multiply the acceleration of motion, which equals 1.4 meter per second square, then the left hand side kilogram times meter per second square. The right hand side equals M times G. M is the mass of the body, which equals 63 kilogram, multiply G, the gravity of the body, equals 9.8 meter per second square, minus the pressure N. Now N in unit, Newton unit. Then N equals 63 times 9.8 minus 63 times 1.4. We can take 63 as a common factor in the right hand side. Then N equals 63 multiply between two brackets 9.8 minus 1.4. Then N equals 529.2 Newton. Or N equals 529.2 over 9.8 kilogram weight. Then the pressure N equals 54 kilogram weight. Another example. A body is suspended in a spring scale fixed at the top of a lift. It's noted that when the lift moves up with acceleration c meter per second squared, the reading of the scale is 8 kilogram weight. And when the lift moves down with acceleration 2c meter per second squared, the reading of the scale is 5 kilogram weight. Calculate the value of c. And if the steel wire carrying the lift cannot stand tension more than 1.2 ton weight. Find the maximum load that the lift can stand as it moves up with acceleration c, given that the mass of the lift as it's empty is 600 kilogram. First, the lift moves up with acceleration c, and the equation of motion is ma equals t minus mg. The acceleration in this case is equal c meter per second squared, and the reading is 8 kilogram weight. The tension equals 8 kilogram weight. Then m multiply c equals 8 multiply 9.8, because 8 in kilogram weight, but ma or mc kilogram times meter per second square. Then the forces in this equation must be in Newton unit. Then mc equals 8 times 9.8 minus the mass m multiply g, which equals 9.8 meter per second squared. We can take 9.8 as a common factor in the right hand side. Then mc equals 8 minus m between two brackets multiply 9.8. This equation is equation number 1. The second case, the lift moves down with acceleration to c, twice the first acceleration. Then what is the equation of motion now? ma equals mg minus t. M is the mass of the body, and the acceleration in this case equals 2c. Then 2mc equals m times 9.8 minus 5. 5 is the reading of the scale in this case. 5 kilogram weight multiply 9.8, then 5 times 9.8 in Newton unit. And 2mc equals m minus 5 between two brackets multiply 9.8, and this equation is equation number 2. Now we solve the two equations. From equation number 1 and equation number 2, we find that 2mc over mc equals m minus 5 between two brackets multiply 9.8 over 8 minus m multiply 9.8. We can cancel mc from numerator and denominator in the left hand side, and 9.8 from the numerator and 9.8 from the denominator in the right hand side. Then the left hand side is 2 over 1, and the right hand side equals m minus 5 over 8 minus m. Cross multiplication. Then m minus 5 equals 2 times 8, which equals 16, minus 2m. Then m plus 2m equals 16 plus 5. Then 3m equals 21, and by dividing both sides by 3, then the mass equals 7 kilogram. Now the required is the magnitude of the acceleration c. Then we can substitute in equation number 1. We find that m times c equals 9.8, or 7c equals 9.8, dividing both sides by 7, then c equals 1.4 meter per second square, and this is the acceleration of the motion in the first case. when the reading of the scale is 8 kilogram weight. And in the second case, the acceleration is 2 times 1.4 meter per second square when the reading of the scale is 5 kilogram weight. Now, the third required. Suppose the maximum load that can be placed inside the lift of mass m kilogram. Hence, the tension in the wire carrying the lift is equal to 1.2 tons weight, or 1.2 times 1000 equals 1200 kilogram weight. Now, what is the equation of motion? Then m plus m dash multiply a equals t minus m plus m dash g. M plus 600 times 1.4 equals 1200 times 9.8 minus m plus 600 times 9.8. The left hand side, m plus 600 times 1.4 plus m plus 600 times 9.8 equals 1000 times 9.8. And m plus 600 times 11.2 equals 1200 times 9.8. Then m plus 600 equals 1050. Then the mass of the load equals 1050 minus 600, which equals 450 كيلو جرام. بكده اعزائي نكون استعرضنا مع بعض موضوع نيوتن ثيرد لو، وعرفنا ازاي نفرق بين 3 كيسز مختلفة. لو كان الليفت موفينج with uniform velocity ساعتها وقتها بتكون الاكسلريشن ايكوال 0، او كان ممكن يكون moving upwards or downwards with uniform acceleration. ابدا ساعتها اشوف انا لو كنت طالع يبقى الريدنج بتاعت السكيل اكبر ولا اصغر من الريل ويت، ولو كان نازل برضو اكبر ولا اصغر. بالمقارنه ديت اقدر احدد the motion of the lift upwards or downwards. By these examples we come to the end of our math program today, and till we meet again, it's goodbye.